Okay, so you might remember from right triangle trigonometry, if we knew a trig function of an angle theta was equal to something, like say sine of theta we know was 1 over 3, then you could be asked, well, find the value of the other trig functions. Find cosine of theta, find tangent of theta, and so on. But you don't know what theta is. So it does take a little work. However, you are still able to figure out what cosine of theta is, what tangent of theta is, and so on. You are still able to find those values. We're going to do the same thing here. Basically, as you'll see in this example, if we know a trig function at theta, like for instance in this example, if we know sine of theta was something, and we know theta is in a certain quadrant, then we can get all the trig functions at theta. So let's do that here. So sine of theta is 5 over 13. Okay, notice that since theta is between 90 degrees and 180 degrees, so here implicitly we're saying theta is in degrees, but really, whether it's in degrees or radians, it doesn't matter. We know theta is in quadrant 2. In other words, if you were to draw theta in standard position, okay, like so, you're going to be somewhere in quadrant 2. I mean, what is theta? Again, we don't know, but that doesn't matter. Okay, so now how do we get the other trig functions? In this case, we're just finding cosine and tangent. All right, well, we have this unit circle, right? Okay, the point P, right, that has coordinates x, y. But we also know that x is cosine of theta, y is sine of theta. And we also know sine of theta, in this case, is 5 over 13. Okay, so now how do you get x, though? So we want x. But how do we get that, though? Well, we're on the unit circle, right? Remember, I said that already, okay? And the unit circle is the graph of this equation, x squared plus y squared is 1. In other words, every point on the unit circle must satisfy this equation, must be a solution of it. In particular, our point P has to be. Okay? All right, so let's get our x then, which again is actually cosine of theta. But again, so from here we can solve for x, right? So let's do that. So we have x squared plus y squared equals 1. Let's subtract y squared from each side, like so. These are going to cancel. So we have x squared here is 1 minus y squared. Okay, now let's substitute. What is y? Y is 5 over 13. Okay, so we're going to use y is 5 over 13. Let's substitute. X squared is 1 minus 5 over 13 squared. And that's 1 minus 5 squared over 13 squared. And that's going to be 1 minus 25 over 169. So we have x squared then is 1 minus 25 over 169. But again, we can subtract those. We have to get a common denominator. Well, 1 is the same as 169. So what we actually have is this. And so that's going to be this here, subtracting the numerators, and that turns out to be 144 over 169. Okay, that's good. So we have x squared, let me rewrite it here, is 144 over 169. Okay, that's good. Now how do you get x then? You take the square root, right? So we have x is, but remember, you're going to have plus or minus because you're taking the square root of 144 over 169. Okay? And so this is plus or minus the square root of 144 over 169, square root of 169. So from here, we're going to get x is plus or minus 12 over 13. Well, okay, well, wait a minute. X can only be one number. What's going on here? Well, we have to choose. But remember, x is in quadrant 2 up here, right? That's what this told us. Well, okay, so what does that tell us about x? X has to be negative. So since x is negative, our answer then, x then must be minus 12 over 13. Let me just fix that. So we get x then is negative 12 over 13, okay? Again, that's since x has to be negative. And so cosine of theta, which is equal to x, right? That's negative 12 over 13. So that's cosine. Sine, as before, was 5 over 13. Well, how could you get tangent? Well, if you remember, to get tangent now, tangent of theta, right? That's equal to y over x. Or if you want, you can actually think of it in terms of sine and cosine, right? We have tangent of theta. One of our identities is this is sine of theta over cosine of theta. Okay, so let's plug in and see what we get. Well, sine of theta, as we have, is 5 over 13. Cosine is negative 12, all divided by 13. Okay, well, I mean, yeah, that's right, but let's see if we can write it out in a nicer way, right? I mean, really, what's going on here? We have this extra 13 down here, right? That's really why it's not nice. But what we can do is rewrite it this way. We have 5 over 13, right, divided by negative 12 over 13. But when you divide fractions, you flip the second. So we have 5 over 13 times 13 over negative 12. Well, how does that help us? Well, this is the same as 5 times 13 over 13 times negative 12. So the 13s cancel, and we get 5 over negative 12, which is, of course, the same as negative 5 over 12. So that's what tangent of theta is.